But my name is Ken Wise. I'm with Cornell, but the New York State Integrated Pest Management Program. Been doing mostly field crops until Don Rutz and Keith Walder, and you guys probably know them, retired a few years ago. So I kind of took over doing livestock IPM type materials. And so I've kind of focused on flies, and now I'm doing some dung beetle work. Um, I'll just say right up front, there's not a ton of people doing research on dung beetles and pastures. There's Dr. Wes Watson, who was actually at Cornell for a while as a postdoc, but he's getting up there in years himself. He helped me a little bit with the information. A lot of the best research is going on outside of the country. So towards the end, I'm going to suggest some research that we're going to look at doing next summer. But I'll kind of give you a general idea of how dung beetles work, some of the different kinds. I will not struggle on trying to pronounce the scientific names. I'll just call them their general kind of what classification they're in. And so see what you think. The recommendations at the end are based on what other specialists have said around the country, and whether they work here or not, I guess we'll see in the future, but it's a start. Let's just put it that way. So these are dung beetles in pastures in New York State. I should have put cattle because I focused on dairy and beef. Why is it? Hold on. Okay, so the reason we're interested in dung beetles is that they compete with horn and face flies for manure in cow pats on pasture. My question is, who do you think made those holes in the top? Oh, I can't ask a question. Well, they're dung beetles. Actually, a lot of times people think, oh, look at all those fly holes. Those are actually dung beetle holes, and there's different types of dung beetles, and I'm going to go through some of those in a little bit here. So some of the features of dung beetles, a lot of times people view dung beetles as kind of these big beetles that create a little ball, roll it off, bury it away from the manure pat, which is one type of beetle, which is the larger ones. But most of the ones that we have in New York are tiny, small, less than a quarter inch. So they range from about 0.1 inches to 2.5 inches. They kind of are black to brown to red and mixes of all of them on different types and different species. And some of them have a metallic look. This is a little video I took of one in a pasture near the Dutchess County office, where I have my office actually that I haven't used in three months, but I did a bunch of videos last summer on dung beetles and fly management. So got another one. It's interesting. See this little tiny dot in the middle here? That's a dung beetle. So you can see the relative size compared to the manure pat. So they are pretty small. The thing is, this was at a meeting I was doing with Aaron Gabriel on pasture management up in Albany in May. So it was a cold day. This was, the manure had just been dropped out of the cow, put on the ground. Less than a minute, I walked up there and there was a dung beetle there. So I always get asked, do I have dung beetles? And most people don't think they have dung beetles. I can guarantee you have some dung beetles at least. And they're pretty good at finding the manure paths relatively quickly. So this is also a video just to give you an idea of the size. Now, if we were that size, that would probably look like a big, huge canyon going down in there. So some of the beetles are larger, like this one. This is a roller beetle making a manure, a ball, all black. So in North America, we have about 90 different scarab, dung beetle species, but only about, literature suggests, maybe as many as 20 actually are effective at moving manure quickly into the soil. So you can see some of these dung beetles are fairly small. These are what we call dwellers, these little black ones. And so there's a lot of different species of little black dweller beetles. And then, you know, they can have an appearance of, you know, a shiny metallic color. So these are scarab, most of these are scarab beetles with the exception of a few that I'll talk about later. They're digging beetles, they're kind of like Japanese beetle. Their bodies are made for digging, as you can see in this arm here on these tunneler. This is a kind of what we call a tunneler beetle. They can dig really well, and I'll show you why in a little bit. Some dung beetles have a horn, and so even the smaller beetles might have them. You may not see them, but the males develop, some of them develop horns. I'm assuming that's for fighting for a female, but that I'm not sure about. But just a you know, a trivial fact about dung beetles. So the antennae are really important on a dung beetle, and they kind of have a distinct type of antennae. As you can see, they kind of like have these laminate segments, and there's usually 3, if not more, of those per side of antennae. And what they do is that they can smell the manure from quite a distance with those antennae. And so they're attracted to the manure pad by odor. That's been proven in research. And they can fly up to 10 miles just looking for dung. I did read in one publication that some species of dung beetles will actually jump on an animal and jump off as soon as they excrete. So kind of like a hornfly and facefly at times. So I also read that certain dung beetles like certain types of manure. So, and there's some recent research that shows that there are dung beetles that are starting to infest dog manure and certain species, but I personally don't know them, but you know, it could be sheep manure might be different than cattle manure versus horse manure and so on and so forth. So that will be interesting to see in the future. So the benefits of dung beetles. Of course, the benefit that we're most interested in is reducing horn and facefly issues in a pasture, because those are some economic pests to your cattle. But it also helps improve nutrient cycling by moving the manure quickly into the soil. All those nutrients and nitrogen and phosphorus and potassium and organic matter back down into the ground. It improves the soil structure. Creates macropores, so you can get better water infiltration over time. I did read that it helps improve forage growth. Just having that organic matter back in the soil also stores some of that nitrogen that may have been lost if you didn't have it. And again, they compete for resources from horn and face flies. So just on a quick note, I heard someone, Keith Waldron told me that there are 300 other arthropods that can call the dung pad its home. And here's 2 particular ones that, or one particular one that you see often. People think it's a pest, but it's not. It's called the yellow dung fly. If you walk pastures at all, you see them. And what they do is they lay their eggs in manure. The larvae are similar to dung beetles in that they feed on the manure, but the yellow fly itself is a predator. So they do generally feed on other smaller insects like possibly horn flies, because they are about half the size of these yellow dung flies. Possibly face flies, but they're a little bit larger. So there's predatory mites in here. There's other beetles that exist I'm going to talk about that are part dung feeders, part predatory. So there's a lot of different things that actually can create a nice little ecology within this manure pad. The problem is the horn and face flies, when left unchecked, can really explode in population. So there are three types of dung beetles, and I'm just going to classify them, or the way they're classified is the traditional one, the one that people think about is the rollers, which are telecoprids or geotroop species. They form a ball. The male and female work together to bury that ball. They lay their eggs inside there, bury it, and as those hatch, they feed on that brood ball is what they call it, and then as they become an adult, they'll go through the pupal stage and then become an adult. They'll come back out and again go look for manure pad. So that's the rollers, and this is a picture of the rollers. Canthon imitator, I guess is the name of this. I don't know where they come up with these Latin names, but they have a reason for them, and I don't question it. So so those aren't as effective at moving manure quickly, but the next two are pretty effective at moving manure quickly. And if we could get more tunnelers in up here, it would be a good thing if they occurred naturally somehow. But there are a group of beetles we call tunnelers, and what they do is they can tunnel down to about a foot deep. They do the same thing with the brood ball. The male and female work together to put multiple brood balls where they lay their eggs in, and basically moving that manure in, within a good foot of under the soil surface. So you got more dung beetles, and you're also increasing your soil structure, the macropores, the water infiltration, because of just this one dung beetle. This is a picture of one of those type of dung beetles. Again, you can see the digging arms it has, good at creating tunnels. This is one of the few dung beetles I found that had a common name, and it's called the bull-headed dung beetle. Thought that was kind of funny. So then there are dwellers, which this is what we have most of in New York, despite another type of beetle that actually occurs in the dung. They're called dwellers. They're very effective again at consuming and moving manure. They just don't do it that deep. They can do it within the pat, or most of them, and I should have put a little like hole outside, because a lot of these will go just outside the manure pad and put a ball into the soil right there, and so they're called dwellers because they don't go too far. They don't dig too deep, but they still move manure down into the ground. So taking that away from the, excuse me, I've got a sore throat. So those are your three types of dung beetles. And these are, again, a picture of dwellers. And those other ones I showed you are videos of the dung beetles. Those are also dwellers. I guess they're in the genus Aphrodius. This is omis, I guess. Didn't have a common name, or I would have put it. So, and you can see how small they are compared to the dime. So the combination of them, they can move manure relatively quickly. And in some of the research I was reading, they've done it as quick as 24 hours, made a manure pat rendered useless to horn and phase flies. But generally it takes 36 to 48 hours, which again is enough time to reduce the population of horn and phase flies, because they need at least 8 to 10 days to go through their whole life cycle. So so that's kind of how they work, and the different types of dung beetles. Again, you guys know this probably better than I do. Horn and phase flies are really a pain. Just to give you a look at when the dung beetles aren't doing their job, this is what you can get. There's probably 50, 60 different maggots right there, and not sure whether those are horn flies or phase flies, but definitely one of the two or both. So, horn and face flies can reduce feeding time. They can be an annoyance, reduce weight gains, and the hornfly itself, they need blood to reproduce. So each hornfly will take at least 20 blood meals a day, will be laying eggs in the manure pats that are in the field. And so when a cow excretes, about 95% of all horn flies in an area are at least on an animal, whereas face flies are only about 5%. So as soon as they excrete, within seconds, those come off, lay their eggs, and they're back up on the animals. So they're feeding a lot on blood. There is some blood loss with those, depending on the amount you have on the animal. They can create a painful bite. Face flies do not bite the animal. They have a sponge type mouth part. They feed on secretions around the eyes, around the tail. Anywhere there's blood, they do feed on blood if they're cut or if there's a wound that is emitting some kind of body fluid. That's what they want. They can be annoyance, as you can see in this video here, but they also transmit pink eye and Berlese eyeworms, so they are a possible health threat to the animal also. I had a little better video, I just couldn't find it, but that leg that came up was, I can talk a little bit about that later, but that was stable fly pressure also. So in 2006, a student of Don Rutz, who was our veterinary entomologist on campus, did all the fly work in New York State for 30 years, retired, but he had a student in 2006 that did a survey of dung beetles and cattle manure on pastures in an organic farm, dairy farm, and a conventional dairy farm. Very few differences, but some of the data is interesting, and I'd like to show you. So what they did is they took two types of methods of collecting the beetles themselves. They did this weekly. They put out pitfall traps, and they baited them with manure they collected in the spring. They froze it fresh, and they would put them on the trap weekly. So they collected enough that they could have over the course of about 10 weeks, I think is what they did. And they would collect dung beetles this way in a pasture. They also use a Berlese funnel, modified Berlese funnel, but they would go and collect manure weekly and put it in there with a little bit of the soil from underneath, and they would collect the beetles that fell out through the funnel here into, there was alcohol solution in the bottom, and they would identify these over the winter. And so you can see the number of samples that were running per week is what they did for 2 farms. And this is what they came up with. These are the absolute numbers between both farms. You can see this, I call it A for, these are the dwellers. There are a lot of different species of dwellers. The thing is, the relative percentage is right around 20% of all the beetles found. If you go down here on the blue section, there's what they call small unknowns. They put it in this hydrophilid, and I haven't talked about the hydrophilids yet, but there's a certain type of beetle, I guess you could call it a dung beetle because it infests cattle manure. But most of hydrophilids, if you look at the word hydro meaning water, those are water beetles, and they're existing in manure. So they're kind of viewing the manure as a way of swimming, I guess. And so the adults actually feed on some of the manure, but the larvae are predators of face flies. I would assume they're also predators of horn flies. Maybe that research hasn't been done, but they actually feed on the larvae of face flies in some of the research I read. And these small unknowns are classifying as hydrophilids. That's 66% of all the beetles that were in those manure pats. And I find that really interesting because they're technically not a dung beetle as we view them, but they're a predator, and they're also eating some of the manure. So I would like to know more about this. There's not a lot of information on it, but There's some European information on it. And actually, I think that's where these came from. This one here called, with the O, these are your tunnelers. There was not very many overall, 37 of the Taurus, 7 of the Pennsylvanias, Pennsylvanicus, and a couple others there. And in total, there's less than 1% of the beetles. This would be nice if this was higher. And then we had this one here, a hister beetle, which is also a predatory beetle. There were 28 of them over the course of a summer. They also feed on the larvae of the flies. The geotroops are the ones we call the rollers, and they found only one, which I find interesting also. So there was a study done in the 60s or 70s by Cornell on dung beetles, and they found very similar results as this study here. The thing is, this Taurus did not exist in New York in the last study. And interesting, I think I get to it later, it was introduced into Florida, and it's kind of been moving around, and it's pretty effective at moving manure from what I've read and what the people I've talked to. So just small differences between the farms. There was more of a diverse abundance of dwelling beetles than the conventional farm, which are all these A's here. The SPs are the hydrophilids, which are kind of like the water beetles. And then we have the tunneler down here. So, and this is, I believe, was a hister beetle. As you can see, most of this, this is excluding all those small unknowns, which would make all this pie look very small, all these other ones. So it'll be interesting to find out what those are. The conventional farm was different in that the abundance of some of the other dwelling beetles versus the Agarnarius. Agarnarius was quite a bit of the dung beetles that were there. So the next graph will show you, someone would say maybe that has to do with using ivermectin. You can't, out of this research, you can't really determine what causes this, because if you look at this graph right here, this shows the abundance of beetles, all the beetles per week on a conventional farm versus the organic farm. And while about a month worth of spring beetles was rather high on the organic farm, these patterns are really close to the same. And as you can see, when this one goes up and falls, the conventional farm also goes up and falls. So there's an environmental factor outside of what management practices you're doing on the farm that are causing the rise and fall in these populations. So the next graph, it takes away all the other beetles except for the abundance of the dwelling beetles. So the ones that just live in the pat and lay the eggs just under the surface. It's amazing that they show almost the identical population fluctuation, whether it was on the conventional farm or versus the organic farm. And these were very different farms. One was in a valley, one was a hill farm, I believe. I just find this very interesting. There was a flood that affected the pastures on the organic farm, I guess. And this is around Ithaca somewhere. I don't even know which farms they were, but it really wasn't the flood that caused the population fall, because the conventional farm didn't get it. And this population fell almost to zero in midsummer there, and then started to rise back up, in August. So there's some natural factors there that are causing the fluctuation in the dung beetles, whether you're using product or not. So their conclusion, and this was like an undergrad, would have been nice to go a little bit deeper into this, but most of what we have are the dwellers in New York, excluding those hydrophilids that they didn't identify. We have a new dung beetle, which is a tunneler, and it was introduced in Florida in 1970. If you look at the research, it kind of shows a pattern of it moving north. Um, they found it, about 7, 8 years ago in North Carolina, and now it's in small numbers here. I'm hoping it increases because it is one of those tunnelers. And she does make a whole list of things that should be looked at in the future. But I think this one particular is important to a beef or dairy producer grazing, in that probably want to extend this from early spring through into the late fall until it freezes, because that'll give you an indication of when a better time to treat animals for parasites, so that manure doesn't affect the dung beetle population. Most of the stuff I've read is that, a lot of beef producers try to treat their animals in the spring when it's cool or cold, which makes sense because those beetles probably aren't that active. This might just help confirm that. So, and of course, I mean, you're going to have to treat some animals that become infected, and I'll kind of get into some management stuff now. And so I would like to kind of take this study and expand it, and kind of trying to come up with some different ways. And the one I've been thinking about lately is, if we could get some areas, like Nancy mentioned that she would be interested in helping with this, and if each maybe extension educator that wants to help with this study pick 2 farms, maybe one that uses products, maybe one that doesn't, or maybe just ones that use different products on their animals. We could start comparing and looking at what species of dung beetles we have statewide instead of just around Ithaca on these pastures. And so if each person did 1, maybe 2 farms, that adds up pretty quick, and that would make for a pretty good survey. If I come up with and I would look at the Berlese funnels and maybe not the pitfall traps, just because the funnels are a lot more efficient at collecting the diversity of beetles that are in the dung pats, because those pitfall traps only depend on those beetles that like to walk. Most of those beetles fly, so that probably is a better method of doing it. And say you collect maybe 2 samples on each farm a week, that's not a whole lot of collecting, although I have to say I collected for that study, and I actually had a car that Cornell used to give me, and you do not want to ride in that car after a summer of collecting all that dung. And my wife used to make me go to the garage and clean up before I came in. So anyway, that's an idea I've had for the future. I'm going to try to get some money for it, but it's kind of hard to get grants for this type of research, I think, but I'm going to give it a shot. I'm going to look at some New York funders and some Northeast funding agencies to see if we might be able to do something like this. Some of the effects of products that have on dung beetles: dewormers can have pretty detrimental effects on dung beetles. Even though you see them, doesn't mean it's not affecting the beetles themselves. The parasiticides will pass through the animals. Some of them can last 1 to 3 weeks. In some horses that they use boluses, they can last up to 20 weeks in manure. It does control your horn flies, though, indirectly, but it does kill them, horn flies and face flies. On the feed-through insecticides, the research isn't overly clear. When I went into this, I just kind of took what people were telling me, mostly academics, that it's bad for dung beetles. Well, when you actually look at some of the research shows it has effects on dung beetles. Some of it shows it has little effect on dung beetles. So I don't know what's going on with that. If maybe the beetles are developing resistances, maybe a pest would, like horn flies have pretty strong resistance to certain insecticides in other parts of the country. Maybe these dung beetles have developed some resistance, but it's interesting that you have such a variety of differences with the same product on pastures. And a lot of this was in North Carolina where Wes Watson is. I did email him back and forth, and he said he didn't have a good answer for why there's such a diverse difference. So I just like to throw this up there. These are some of the more recent resources on ivermectin. A lot of it's outside of the country. There's a few more recent than these that I didn't put up here yet. But you know, it doesn't seem to affect the adults as much as it does the larvae. It seems to reduce the number of larvae reaching adulthood. It also affects the ability of the beetles to smell and some of their movement patterns, so that might affect their ability to move manure quickly. So it's maybe, you know, I talked to some growers, producers, I'm sorry, that have went out and sampled and said, I got lots of beetles, you know, and I use this, and you know, they probably do, and they're probably being fairly effective, but it could also be that it might just be affecting as a part of the population, and maybe not so much the adults that you actually see in manure pot. And again, the time of the year makes a big difference also. So again, environmental factors affect any kind of living organism, and you know, dung beetles need moisture. I think that's why those hydrophilas like cattle manure, because it's so soupy and they can swim through it. Dung beetles the same way. But I do think soil type has an effect. You know, gravelly soil is probably not as that great on any beetle. Elevation might affect it. Slope, north facing slope versus south facing slope. Dryness, drought. You know, I think if I remember right, 2006 had a droughty year, but I might be wrong on that. At least where I was collecting manure, I remember the side slope seeming pretty dry. If you can, limit the use of dewormers so that your dung beetle populations can increase. Use if you have the land for it and the setup for it and the fencing for it, you know, making shorter rotational grazing intervals, so you make the paddock smaller, you increase the amount of manure in one area, which keeps those beetles around. And so you move over to the next paddock, it's not too far to go to the next one, and then you just have more manure in a smaller area, which would create more beetle in that small area that can move on to the next paddock. Because what they do is they'll come out and they will go looking for more manure. So they do suggest several specialists around the country, if you can afford it, if it's not too costly, you can test your manure for parasite eggs, and if they don't really exist at any high levels, whatever the threshold is for that, you know, maybe it's best not to deworm them, just on an annual basis if you don't need it. On fly management, I know feed-throughs are popular. I know they control them, but we will always recommend treating the animals when they need it. So the we have action thresholds. They're not true economic thresholds, but these were developed by Don Rutz at Cornell, and they say an average of about 200 flies per beef animal is the point of when you probably want to control those flies. And that's 100 per side. And that picture there is well over 100, even though it may not look like it. You know, what I did is I started taking pictures of the flies on animals and then blow them up and count them, because that doesn't include all the other ones on part of it. Because horn flies do exist on the belly also. So these are all horn flies. He suggests 10 face flies per animal is the point at when you can control. And I didn't talk anything about stable fly because they don't breed in the manure pat in the pasture. They breed in decomposing manure infested hay, or hay on pasture that's not picked up that gets moist and it has a soil to grass connection there. That's prime habitat for stable flies, and those are, you probably know better than me. I go fly fishing a lot, and they like to breed in and around lakes on some of the weeds that get wet along the edge, and they do bite pretty hard. So they so he suggests 10 per 4 legs on an average of about 15. This is all on an average of about 15 animals. So if a control is needed, you know, use back rubbers, dusters, face rubbers. You can do direct animal sprays, pour-ons, dusts. Most of that stuff doesn't end up in the manure as you would do a feed through. So that's just a consideration that you might think about in the future. And so our goal is for these dung beetles to move the manure into the ground quickly so that we can break that life cycle. Because again, horn and face flies need at least 8 to 10 days to become an adult. If you take it away, then you're limiting the number that you're going to actually have on your animals. And in some studies I read, one in particular, where they measured the amount of horn flies developed in paths that had dung beetles versus ones they excluded, that they reduced the population by 95%. So that's it on the dung beetle part. Just to let you know that we have a ton of resources that were developed by Dr. Don Rutz and Keith Waldron, which recently retired. They were both veterinary entomologists. That Keith worked in our program. Don was a faculty member at Cornell. And there's a ton of publications on our New York State IPM website, Integrated Pest Management website. And if you go here under livestock and field crop publications, you'll click there, you'll pick cattle, and you'll have at least 10 to 15 different publications on management of flies and mange, lice, and a lot of different things, and different methods of control that you can use. With that said, probably in the next 2 weeks, I have a publication that I'm having reviewed by the pesticide educator or pesticide education group on campus. And it's a list of all the insecticides you can use on dairy animals. Well, all those products that you can use on dairy animals, you can use on beef animals. I am going to put together a beef one too, because there's more products that you can use on beef than you can use on dairy. But there's a ton of them. When I did the search, 300 products are available for use on animals for controlling flies. So, and some of them are for controlling ticks. So, we also have our YouTube website, our channel, station, whatever you want to call it. We have a lot of different videos on fly management, ranging from 2 minutes all the way up to an hour and a half course on fly management, on mange, on ticks. I recently did about 16 different videos, short videos. You can see them there. The biological control of barn flies, house flies, alternative management practices for house and stable flies. There's horn flies, face flies. There's actually alternative trapping techniques, biocontrol, and they're both in English and in Spanish if you need to show it to some coworker or some of your workers, or whether you can speak Spanish. So those are available on our YouTube channel. So with that, are there any questions?
All right.